Okay, so this week we're going to be talking about sorting algorithms. You'll notice that I've got a very slightly different background behind me. I'm actually in Germany this week, visiting the maths department there, so you'll probably see maths equations on the blackboard behind me. I'm going to do this in a series of fairly short videos because I'm sharing an office with somebody and basically they can come back at any point, and also people keep popping in and trying to speak German to me. So I'm going to do it as a fairly short video just so that if I get interrupted I can then re-video it. I hope that's okay. So what we're going to do is first of all introduce you to the idea of sorting algorithms. Then we'll look at 5 sorting algorithms, which are selection sort, insertion sort, merge sort, quick sort, and bucket sort. We'll then discuss a little bit more about sorting algorithms. We'll look at stability of sorting, and we'll also look at choice as to which algorithm you should use when. So, what is sorting? Sorting is the process of ordering data, either in ascending or descending order. That is based on the natural order. So, for example, if it's numbers, it's usually like 1, 2, 3, is the order you used. Or you can actually specify an order as well. So you could say, for example, I want all the even numbers in order, then all the odd numbers in order, and that would still be technically ordering the data. Usually, though, it's numerical order, or in the case of it being words, it's alphabetical order. Sorting has lots of really useful applications. In fact, it's one of the algorithms we do use a lot in computer science. So the main way it's looked really is data processing. Anytime you've got lots of data and need to look through it, you usually sort it first. So for example, a university may need to process applications in order based on the time the application was made. And actually there's another way you can sort data, is based on time. Okay. So we need to sort the data, keep the applications in the order in which they arrived to make sure they're done first in, first out order. So that's quite a normal thing to do. The other reason we tend to sort data is for efficient data lookup. So a binary searching algorithm, next we'll be looking at searching algorithms, and a binary searching algorithm, which is a lot faster than linear searching, requires the data to be sorted first. So often we sort the data just so we can look it up efficiently. So a sorting algorithm then is an algorithm that's used to sort data. As I said, you can sort it in any way you like. The algorithm specifies the rules and heuristics to be followed when sorting the data. So the rules are things that you have to do. The heuristics are things that you may choose to do, and we'll come on to that in a bit more detail when we talk about things like quicksort. There's heuristics for how you may choose to sort the data, but you don't always have to do it that way. Rules are things we follow. Heuristics are kind of a rule of thumb. That's another way to think about it. It's like, this will probably work well, so we'll do it that way. We're going to look at some of the most common sorting algorithms. We're going to look at selection sort and insertion sort, which are 2 fairly old-fashioned sorting algorithms now, but I think it's worth covering them because they're the basics and the ones that people still think about when they think about sorting. We'll then look at 2 what we call divide and conquer algorithms, far more modern algorithms, merge sort and quick sort, and then we'll look at bucket sort, which can use a different mechanism, use the data structure to sort. So hopefully, by the end of learning those 5 algorithms, you'll get a good idea how sorting works in reality. Okay, I'm going to stop this video now, and I'll see you in a while to talk about selection sort.